Welcome back to Niagara Learning. Now, with this time we're going to deal with a water meter. Someone's asked a question and they want to find out what the cubic meters is of a water meter, and there's 10 pulses per litre on a water meter. So first of all, what we'll do is we will make a new folder, and we'll just go water meter pulses, go OK to that, and we'll go into that, and then we'll put in just a numeric just for now, water meter pulse, and we'll just take out our in16 just to keep it nice and tidy. And that's going to be 10 pulses is equal. So let's just set that to 10 at the moment. 10. We don't need the 0.0 because it's not decimal. So let's just take that out. And that's just a pulse. So we've got water meter pulse there. So that's 10 pulses. And we need to transform that into meters cubed first. So we're going to do a multiply. So go to our maths, multiply, and this is going to be meter cubed. And we take the 10 and we times it by 0.01. Save that. And we can take that as, don't know whether that's right yet. Let me just go to meters cubed, OK, and let's just put 2 decimal places because that 0.01 is wrong, because I believe that 10 is 0.01. So I need to change that to another 0, I think. So I believe 1,000 is 1 meters cubed. So let's change that to 1,000. 1,000 litres is 1 meters cubed, so that's right now. So let's just put some text above this. Note. And 1,000 litres equals 1 meter cubed. I think it's a little L and then big TS. No, that doesn't look right either. Save. 1,000 litres equals 1 meters cubed. Let's just go back into that, take that to there. Let's put a background on there just as a, so that we can clearly see it, and we'll put a border around it. 1,000 litres equals 1 meters cubed. That's 1,000 litres, that's 1 meters cubed. Now we also need to get flow rate. Now that's going to work on the hours. So let's just take a note, duplicate that, and let's make another note. And flow rate is 1 meters cubed an hour. So 1 m3 stroke h equals 0.277778, but I'll just do 0.28. Although we could do, being precise, I think it's 4 sevens. 1, 2, 3, 4. We just check that. 1, 2, 3, 4, 8. What I'm looking at there is this, just so that you can see. 1 meters cubed an hour equals 0.2778, just in case you think I was looking at existing logic or whatever. I'm not. I'm just doing this on the fly. So flow rate 1 meters cubed equals that. Save that. So that's going to be 1 meters cubed an hour. So that's 1 every hour. So what I would do, if it's Trillium, is I would go into my energy. I'd put a sliding windows demand calculator in there, and I'll expand that lot. I know it's in kilowatts, don't worry about that. Let's just we're just using it for meters cubed. We can change the text later, and we want to put in there the, where are you, current pulse count, so we can see that as well. So current pulse count. So what we will do there is we take that meters cubed, we will put it into our current pulse count, and then we will say current pulse count. So that's 1. It's actually meters cubed, not that. And that's the rollover, and that's the hourly. I think what I need to do now is actions, set that to 10 because that's a pulse, and we need to do something to make pulses to test this out over time, and then come back to it and see whether it works. I'm just wondering, what I will do though is on this M3 block that I've done, so let's expand that, and where we've got the M3 multiplier there, now let's just take that back out, and let's just put a duplicate Watermeter M3. Let's just put that into that one there, and then we take that out, and that's our current pulse count. And we can set that facets to M3, and then I'm going to put in there, in the control palette, kit control extensions, I'm going to put a numeric totalizer in there, into that one, and I'm going to check the numeric totalizer, and I'm going to either minute or hourly, so I'm going to set that to hourly. Save. I'll expose them to the, so composite them out, numeric totalizer total, expose them out while I'm at it. Expose that out, might as well, there's no harm in it. That should give me my total per hour without actually using the Windows, sliding Windows demand calc, but we need to test this out, so I need to put a pulse in there. So if I go to utilities and use a, what can we use, a ramp? No, I'll tell you what we can use, forget that. I'm going to go into my timer and my Boolean delay, put that as a test point, and we are going to set it so that we have got that to 1 minute. Save. So there's 60 minutes in an hour, of course, we all know that. So every 1 minute now, that is going to pulse. Now, he's got 10 litres of pulse. There's 1 meters cubed. So if that's going to pulse, that's going to pulse 10 litres. So we just want to times that now in our, where are we? Multiply. Where are you going to? Multiply. So we need to put a counter on there. Counter, counter, counter. Counter. We don't need any zeros there. Save. So every pulse that makes, we're going to count up 10. So that then can go straight into. So that's made 1 pulse at the moment. Let me clear that out. So when it makes another pulse, that will be 10 value. And let's just put some text there. Note. Started at 12:20. Started at 12:20, 8th of the 9th, 2023. So we've already got 10 at the moment there. So that's 1 minute gone. That is pulse every min. And let's expose this so we can see pin slots. On delay, off delay. On delay every 1 minute, off delay every 1 second. Alright, let's see what happens in a bit. I'm going to put you on pause and we'll see what happens later. So just to give you a view what's happening at the moment. So we're now in 90 pulses. So that's 0.09 meters cubed. And we haven't got anything on the total yet that we put in there, which we wouldn't do because it's hourly. And we are getting 0.1 at the moment in our sliding window demand calculator. But that was at 12:20 and it's now 12:30, so we've only done 10 minutes at the moment. We've just gone up to 100 there now, and that's gone to, well, it's still 0.1, but we'll see what happens within an hour. And we've got then 1,000 pulses. Put you on pause again. Okay, I've just duplicated this meter pulse hour down here, and I'm just going to change this to minutes, just so I can see what's going on. I'll put that now into there. I've added the value there, 0.01, which is in B. You can't see it, you think it's 0.00, but it's not, it's 0.01. So we're still counting up. We've done 210 pulses now. The time is 12:41. And I changed the facets here to meters cubed. And all I did for that is change the top facets, consumption facets there, from kilowatt hours to meters cubed. And really we want to do the same with the demand facets, and we do the same with the kilowatt pulse facets. save, and go back out. So everything's now meters cubed here, and I just changed the text here from kilowatt hours to meters cubed an hour. And again, that's easy done by just going to the AX slot sheet, clicking on that. It was kilowatt hours, I've changed it to meters cubed an hour. I've done the same with all them. Okay, I'll put you on pause again and we'll see where we are later. So I haven't stopped anything from working, I've just added in some extra bits here. A countdown timer, so I can actually count down, so I can see how long this counter's taking before it gets reset. And then when it gets to 600, I've decided to stop the pulses so I get an accurate figure, just in case I forget closer to the time, which the time now is 13:11, so we haven't got that long to go anyway. Now it's 12:20 I started, so 13:20 is when it should reach 600 pulses. It's reached 510 at the moment, so we'll just wait and see what happens. I reckon we're going to be using the 1 hour timer that's built into the logic with the numeric totalizer. I reckon that's what we are going to be using to give us our value, because I really want that to be 0.27778 or thereabouts, and it's already 0.22, so I reckon that is going to work. And I believe that this is going to be a load of rubbish for sliding window demand calculator. But we'll see at the end of the time. Put you on pause again. Okay, so we've just reached the hour. We're at 600 pulses there. Time now is 13:21, so we've gone over the 13:21 and we're 0.312. So I'm not too sure whether that is good or bad, but because we wanted 0.277778 and we haven't got that, so I think we will. We haven't got the 0.27 here either, have we? Oh, we got it pretty close, 0.271, but not 0.27. I think what I'm going to do is reset all this lot and do it again, and then we can look at it. So let me actions and reset timer, actions, reset total, and clear the preset. That's at 10, let me clear that. Clear. I think that's it. That's all reset. Why is that giving me litres? Action, reset. Okay, that's giving me zeros now. Time is 13:23. So 13:23. Save that. We haven't had a pulse yet. We'll get another pulse in 8 seconds. So I'll log the time when it's pulsed, which is still 13:23. And then I won't mess around with the logic. I don't want that. I want 13:23. 13:23. Save. So there's our 10 going through there. That is not at 600, so that's going to be false. When it's true, it's going to put the 600 through. Otherwise, it would just carry on counting up until it gets to 600. And then we'll see what the value is again. I'm trying to get 0.277 as a value. So I'll leave that alone now. I won't touch anything. and we'll see closer to the time. Put you on pause. So we're halfway through now. So that's 300 pulses. Time is 1:53, and we're reading 0.075 litres a second. So we'll see how we get on when we get to the full 600 pulses 1 hour. So it looks like we've reached the 0.27778 litres a second, 0.28220, and yet we still got, we're at 580 there, so we still got another 2 more minutes to go. It's 13:23 and it's now 14:22. So it's slightly out, but I would go with that one. I would use this block here, and I would add to it the numeric totalizer, because it's near enough there on the litres per second for an hour, meters cubed an hour. But yes, we've gone above it. It's 2927, and we've still got 1 more pulse to go in another 55 seconds to reach the 600. I'm going to end this video, but what I'm going to do is I'm going to keep this running and see what it's like in 24 hours. But I probably won't be showing you that. As for the windage demand curve, meters cubed an hour, we've got 0.220 there. So it's not 100%, but let's just put a numeric writable in there. Take that meters cubed an hour across into there, and let's change the decimals to 6 and see what that looks like. It's just doing 0.23. So you could use a sliding window, but you probably, the good thing with the sliding window is you've got the last hour, and then you've got the daily, the last day. So that is good to have that information there. But if I was to use, I mean, we're at 600 now, so we reached our 1323, and we're at 0.31, and it should have really been 0.27, but it's not that much out. So I would go with that. Okay, thank you for watching.